Welcome back once again. Last time we looked at actually querying our data for the first time, right? We have our stocks data in our database and now we're starting to really do stuff with it. Super exciting. Well, in this video, we are going to take that a step further and look at one of TimescaleDB's most popular features, this being continuous aggregates. And before we just jump right on into creating the continuous aggregate, we're going to do a little bit of background information to kind of give you a base of understanding for what continuous aggregates are, which I think is always very important. So let's jump right on into actually explaining and understanding continuous aggregates better, and then we will create our first continuous aggregate. So in the last video, we talked a little bit about how the time bucket function allows you to bucket time series data based on a specific interval so that then you can aggregate other data over that specified interval. And really, continuous aggregates use this at its base. So continuous aggregates are improve upon Postgres materialized views. So you have all the functionality of Postgres materialized views, but also the ability to automatically refresh portions of your data so that you can have updated data without losing any historic aggregated data that maybe you changed kind of the underlying data within the hyper table that you're aggregating on. So for those of you who are unfamiliar with Postgres materialized views, important to understand, they let you take a query and snapshot the results and then put those results into a special Postgres table. So when you hear the word materialize, you can loosely think of it as storing, right? Storing the results from a query, roughly. So getting a continuous aggregate up and running is a two-step process. So the first is actually creating the continuous aggregate. And then the second step is adding on an automatic refresh policy. So that automatic refresh policy is what keeps your aggregate up to date. The first time you create your continuous aggregate, it one time will materialize all the data that you specify, but you have to call that refresh policy to keep that data up to date. And if you choose an automatic refresh policy, it will automatically run continuously and keep your data up to date. So in this video, we're only going to be focusing on the first part, the first step, so creating the continuous aggregate. Now, before we jump into actually creating the continuous aggregate, it's helpful to kind of look at what's happening graphically when we create it. So this is an image that represents how continuous aggregates work upon creation. So the continuous aggregates take data from an underlying hypertable and aggregates it over a set time interval, then materializes that aggregation in the continuous aggregate. So the horizontal lines represent time and the orange dots represent your data plotted over time. So the small orange dots are your raw data points, and then the large orange dots are the aggregated data that's materialized in the continuous aggregate. So then these grouped boxes with the arrows represent the time bucketed data and then the aggregation acting on it. So if you notice, the first four shown from left to right are showing time intervals that are fully done, right? Say it's daily data. These are 4 full days where you have data that's aggregated and materialized into the continuous aggregate. If you notice then the last one that's shown, right, there's a dot missing. We only have 3 instead of 4 dots shown. So this represents a time period that has not fully passed. So if it's daily data, maybe it's right now when you create the continuous aggregate, it's 7 p.m. or something. And then this day's bucket is not complete, right? The day has not fully passed yet. And I mention this because when you first create a continuous aggregate, even if the full time period has not passed, we will materialize, or the continuous aggregates will materialize that data, that aggregated data by default, even for incomplete time buckets. This is not true when you refresh your data. When you refresh, an incomplete time bucket will not materialize the aggregated data. So we'll get more into that in the next video, but it's good to note that by default, when you first create the continuous aggregate, all the aggregated data will be materialized. So just good things to note when you first create your continuous aggregate. And keep in mind that this materialization allows you to have that quick, easy access to aggregated data. Now, this was a very brief explanation. If you want more information, definitely check out the documentation because we have lots of more details in there that you can kind of sit with. So we understand continuous aggregates. Let's actually create one. All right, so our first step is that we actually want to formulate an aggregation query that we can then use within our continuous aggregate to create it. So a very popular aggregation type with stock data is called a candlestick. And a candlestick is made up of 4 aggregates for each day. In this case, I mean, it can vary depending on the type of candlestick you make, but often you'll have a candlestick or candlestick data over a day. And essentially, how this breaks down is that you have the 4 aggregates, that make up the candlestick are first an opening stock price for the day, the highest stock price, the lowest stock price for the day, and then the closing stock price. So the opening stock price is the first stock price for the day, closing is the last stock price for the day. And so we can create this aggregate for our data using this query. So if I call this query right now, I'm going to start it as I explain it because it takes a little bit of time because, it's taking all of the data from my stocks real-time hypertable and aggregating on it and then giving me the results. Okay, so if we break this down a little bit, so we're selecting, because calling a select statement, then we're using the time bucket function. So we're specifying, that we want to bucket by day. We want daily aggregation in this case. So we're time bucket function, our interval is 1 day. We're calling it on the time column because that's our timestamp column. So I'll rename our time bucket as day. And then I also want to call symbol. So that's the next column that I want to select. And this is because, I want daily candlestick information per company. So in this case, I'm going to have to group by both the day and the company. So I need to call that symbol column value. So then we have our 4 aggregations. So max price gives us the highest price per day. First price when ordered by time, because its time ascending, is going to give us the opening price for the day because it's the first time period. We're getting the first price for the first time period. And then last price time gives us the closing price because it's giving us the last price for the latest time for each day. So that's closing price. And then min price is our low. All right, cool. From our stocks real time table, cool beans. And then we're grouping by our day and symbol, We want the daily candlestick data for each company. And then I'm also going to throw in an order by because, inherently, as we talked in our last video, Postgres does not order your data by default. So we want to order it by day and then by symbol. All right. So this is the query that we want to use to create our continuous aggregate. Awesome. So now that we have the query, we can actually create the continuous aggregate. So how we create the continuous aggregate is so. We call create materialized view because, continuous aggregates kind of extend materialized view functionality. So we create a materialized view and we name our continuous aggregate. So in this case, I'm going to call it stock candlestick daily. And then in order to make sure that the system knows to create a continuous aggregate and not just a plain materialized view, you have to do this with TimescaleDB.continuous as. So this kind of lets the system know that you want to create a continuous aggregate. So that TimescaleDB.continuous, and then after the as, we can then specify the query that creates the continuous aggregate. So in our case, we use the select statement, but notice that we don't include the order by in this case. And that's because we don't write in the aggregation when it materializes or stores the data, we don't need to order it. We can, whenever we query from the continuous aggregate, we can use an order by if we would like, which we will do. So go ahead and run this SQL. We'll run this statement, and our continuous aggregate will be created. And then just to show you how much faster it is to query from the continuous aggregate rather than calling that big long aggregation query that we did before, if we select all from our continuous aggregate, we run that and boom, instantaneous. It's way faster. So that's really the benefit of continuous aggregates. Awesome. And there we go. All right, friends, so we created our first continuous aggregate. Now, right, we need to set up the second half of this journey, and that is to create an automatic refresh policy. You will not be done in creating your continuous aggregate without setting up the automatic refresh policy. Okay, you don't get half of the really useful stuff without setting up that automatic refresh policy. So make sure to watch the next video, all right? And if you wanna make sure that you don't miss any of the awesome content that's coming from the rest of the series, like compression and retention policies, you'll want to smash that subscribe button. And as always, if this video was helpful or if you enjoyed it, we always appreciate likes and comments below as well. Since I'm gonna see you in just a second, because you're gonna set up your refresh policy, I'm not even gonna say happy coding. So I'll see you in a little bit. Bye.